I need you to look at two numbers that the Met Office published just 3 days ago on August 2nd, 2026. The first, Arctic sea ice extent on that date was 7.02 million square kilometers, the ninth lowest in the satellite record going back to 1979. Not alarming on its own, within the range of the modern record. The second, Antarctic sea ice extent on that same date was 65 million square kilometers, the fifth lowest on record for that time of year. And here is what I need you to understand about why both of those numbers matter at the same time. The Arctic and Antarctic sea ice systems are on opposite seasonal cycles. When it is summer in the Arctic and sea ice is melting, right now in August, it is winter in Antarctica and sea ice should be at its maximum seasonal extent, building toward its annual peak. The fact that Antarctic sea ice is simultaneously at its fifth lowest on record for early August, during what is supposed to be its seasonal growth phase, while Arctic ice is at its ninth lowest during its melt season, means both poles are underperforming their historical baselines at the same moment in the same direction, simultaneously. Scientists at the Met Office stated plainly on August 2nd that the Antarctic system was below average across roughly half the Southern Ocean, spanning from the Weddell Sea to the Indian Ocean sector. And a study published just months ago in Science Advances, after years of confusion among researchers about why Antarctic sea ice collapsed so suddenly and dramatically beginning in 2015, finally delivered a scientific consensus answer, along with a warning that I don't think is getting enough public attention. This is Weather Signal, and I'm going to tell you exactly what happened at both ends of the planet, what scientists did not expect, and what it means for your weather, your coastlines, and the next decade of Earth's climate. Let me start in Antarctica, because I think the story of what happened to Southern Ocean sea ice over the past decade is one of the most scientifically significant and publicly undercovered stories in modern climate science. For decades, roughly from the late 1970s through 2015, Antarctic sea ice was one of the most puzzling features of the global climate system. While the Arctic was losing ice dramatically and consistently in response to global warming, Antarctic sea ice was behaving strangely. It was not declining. In some years, it was expanding slightly. Scientists referred to this as the Antarctic sea ice paradox, and it generated genuine scientific debate because climate models predicted Antarctic sea ice should be declining, just like the Arctic. Then 2015 happened. Antarctic sea ice reached a record low minimum that year. And then, instead of recovering, it continued downward. The winter maximum in 2017 set a record low winter extent. The minimum in 2022 set another record. In February 2023, Antarctic sea ice reached its absolute minimum extent since satellite records began, a number so dramatically lower than anything in the historical record that the scientific community described it as a 5 sigma event, meaning a departure from average so extreme that in a stable climate system, it would be expected to occur less than once in hundreds of thousands of years. At that point, scientists couldn't fully explain what had driven the 2023 collapse. Various hypotheses were offered. Strengthened westerly winds, ocean heat intrusion from depth, coincidental natural variability layered on top of a warming trend. And then, earlier this year, the journal Science Advances published the study that finally gave researchers clarity. Using ocean observations to reconstruct the sequence of events, scientists at the University of New South Wales and the University of Southampton showed that it was strong winds that disturbed the Southern Ocean's vertical layering, replacing cold and relatively fresh surface water with warmer, saltier water rising from below. That warmer, saltier water caused initial melting. And then, in a feedback process that researchers described as compounding acceleration, as sea ice declined over the following years and reflected less sunlight back to space, the ocean absorbed more heat, which further accelerated ice loss. The system locked into a new state. The first author of that study, physical oceanographer Aditya Narayanan, described the current situation in words that I think deserve to sit at the center of how we discuss Antarctic sea ice going forward. He said, "The system is behaving in a different manner. Obviously, something has changed." That language, "the system is behaving in a different manner," is not scientific hedging. It is a precise description of what oceanographers observe when they compare the modern Southern Ocean to the ocean of the 1990s and early 2000s. The system is not just warmer, it is structurally different. The thermal layering that previously insulated the deep, warm water from the sea ice above has been disrupted in a way that is now self-reinforcing. And as of August 2nd, 2026, Antarctic sea ice extent sits at its fifth lowest for this date in the 48-year satellite record. The system that scientists spent years trying to understand is behaving exactly as the Science Advances study would predict it behaves now, persistently below its historical baseline, driven by a changed ocean structure that does not automatically restore itself between seasons. Now let me shift to the Arctic, because the August 2nd Met Office briefing contains specific information about what is happening in the far north right now, and it is the kind of precise, data-grounded assessment that should inform how every coastal community in the Northern Hemisphere thinks about the coming decades. Arctic sea ice extent on August 2nd was 7.02 million square kilometers, placing it 9th lowest in the satellite record. The Met Office was careful to note that September Arctic sea ice extent remains uncertain, and there is not yet any indication of a value either extremely high or extremely low relative to the post-2007 range. That is honest scientific communication. The September minimum is still 2 to 3 weeks away, and Arctic sea ice has a history of surprising forecasters in both directions during August and early September. But here's the context that gives the 9th lowest August 2nd, reading its full significance. The lowest August 2nd Arctic extent ever recorded was 30 million square kilometers, set in 2020. The current 7.02 million square kilometers sits closer to that catastrophic 2020 value than to the long-term average. And the long-term trend in Arctic sea ice, the one that has driven nearly every September since 2007 to record low or near record low territory, is not reversing. It is the persistent background signal against which each year's specific conditions play out. I'm going to explain exactly why Arctic sea ice decline matters for weather in the continental United States, because I think this connection is one of the most important and least intuitively understood links in the climate weather chain. The Arctic amplification signal. The fact that the Arctic is warming 2 to 3 times faster than the global average has a measurable effect on the jet stream, the atmospheric river of fast-moving air that separates cold Arctic air masses from warmer mid-latitude air. As the temperature difference between the Arctic and the mid-latitudes decreases, the jet stream slows, becomes more wavy, and tends to stay in fixed positions for longer periods. A jet stream that is more wavy and slower moving produces atmospheric blocking, the kind of persistent high-pressure systems that produce the heat domes I've been documenting this summer. A jet stream that locks into position produces the kind of pattern where one region gets weeks of continuous heat, while an adjacent region gets weeks of flooding rain. The 2026 North American heat wave, which killed at least 44 people in the eastern United States, broke all-time temperature records in Billings, Montana, and Salt Lake City, Utah, and pushed Phoenix to sustained periods of 113 degrees without dropping below 90 overnight, was an expression of exactly this blocking pattern. And the Arctic sea ice decline that is contributing to jet stream waviness is not a future forecast. It is a current, ongoing, documented physical change that is measurable right now in the August 2nd data the Met Office published 3 days ago. The title of this script references what scientists didn't expect, and I want to be precise about what that means, because the scientific community's use of the word unexpected is specific and important. I am not suggesting that scientists were surprised that the poles are warming. They expected that. What they did not fully anticipate were 3 specific features of the current polar transition that have emerged in the data and that have significant implications for how the rest of the climate system behaves. The first surprise is the speed of the Antarctic collapse. Climate models that ran simulations of Antarctic sea ice through the 21st century under various warming scenarios did not predict the abrupt nature of the post-2015 decline. The models generally showed a gradual, relatively smooth decline in Antarctic sea ice over decades. What actually happened was an abrupt step change, a system that appeared relatively stable for years and then shifted rapidly to a new state with little warning. The Science Advances Studies explanation involving Southern Ocean vertical mixing disruption provides the physical mechanism, but the timing and abruptness were not captured in advance by the modeling community. When the world's best climate models fail to predict and observe change, it typically means the models are missing either a process or a feedback loop. Understanding which one and incorporating it into future models is essential for making reliable projections of what comes next. The second surprise is the persistence. Scientists expected that years following a record low Antarctic sea ice minimum might show some recovery, at least partially, as natural variability provided favorable conditions. The 2026 minimum, which NSIDC reported at 58 million square kilometers and described as the 16th lowest in the 48-year record, substantially higher than the catastrophic 2023 minimum, was initially received with cautious optimism. But the winter of 2026 is now showing the 5th lowest August extent on record, meaning the better 2026 summer minimum has not translated into a robust recovery of winter growth. The system improved slightly from its worst values and then slid back toward below average territory without recovering toward historical norms. Scientists at NSIDC were clear that the improvement is real, but equally clear that one better season does not constitute a recovery. The third surprise is the simultaneous nature of what is happening at both poles at the same time. Earth. Org documented the 2022 event, which provided the template for understanding this kind of dual polar extreme, when both Earth's poles underwent simultaneous extreme heat events with temperatures in Antarctica soaring up to 40 degrees Celsius above average, and some areas in the Arctic hitting more than 30 degrees above average at the same time. The simultaneous nature of that event alarmed climate scientists specifically because prior understanding suggested the poles shouldn't routinely experience simultaneous extreme departures from average, given that their atmospheric connections are indirect. What we are now understanding is that a warming planet has created pathways through atmospheric teleconnections, through changes in the global ocean circulation, and through the El Niño-like reorganization of tropical heating patterns that can drive simultaneous anomalies at both poles. And El Niño, which NOAA has confirmed is now officially present and strengthening toward very strong status, is one of the most powerful known drivers of those teleconnections. This is the link I want to spend time on, because I think it is the piece of the puzzle that connects everything I've been tracking on this channel in 2026. The heat waves, the tropical storms, the drought, the wildfire risk, and now the polar behavior, into a single coherent story. El Niño, confirmed by NOAA as officially present since June 11th, and given an 81% probability of reaching very strong status by fall, does not just affect the weather in the United States. It reorganizes the global atmospheric circulation. Here is the mechanism in plain terms. El Niño warms the central and eastern equatorial Pacific Ocean. That warming changes where the most intense, deep tropical convection, thunderstorm complexes that pump enormous amounts of heat and moisture into the upper atmosphere, occurs. Normally, that convection is concentrated in the western Pacific near Indonesia and the Philippines. El Niño shifts it eastward toward the central Pacific. That shift in the location of the atmosphere's primary energy input triggers what atmospheric scientists call a Rossby wave response. Wave-like disturbances that propagate poleward through the atmosphere, altering the position and character of the jet streams in both hemispheres. In the southern hemisphere, the El Niño response typically involves changes to the southern annular mode, a measure of the position and strength of the westerly wind belt that encircles Antarctica. When the westerlies shift, the ocean mixing dynamics that the Science Advances study identified as the mechanism of Antarctic sea ice collapse can be either enhanced or suppressed. The 2015 onset of Antarctic sea ice decline occurred during the developing phase of the 2015-16 Super El Niño, the strongest El Niño in the modern instrumental record before 2026. The current El Niño, which NOAA and the European ECMWF system both project will rival or exceed the 2015-16 event in intensity, is developing on top of a southern ocean that is already in a structurally altered state. The combination, a super El Niño amplifying the circulation changes of an already disturbed southern ocean, is something that has no direct historical analog in the observational record. In the northern hemisphere, the El Niño Rossby wave response amplifies ridging over the northern Pacific and alters the position of the polar jet stream in ways that favor the blocking patterns responsible for this summer's heat domes. The heat dome that killed 44 people in the eastern United States and broke all-time records in Billings and Salt Lake City is, in part, a manifestation of the same global atmospheric reorganization that is producing anomalous conditions at both poles simultaneously. The heat in Montana and the ice loss in Antarctica are not separate stories. They are the same story, told in different geographic languages. I want to be direct about the most concrete, most directly life-affecting consequence of what is happening at both poles simultaneously, because I think it deserves unambiguous communication rather than the hedged, conditional language that sometimes surrounds sea level projections. Ice loss at both poles contributes to sea level rise, and the ice at both poles is behaving in ways that scientists did not fully anticipate in terms of speed, persistence, and system-wide change. The West Antarctic ice sheet, which is grounded on bedrock that sits below sea level, is particularly vulnerable to the kind of ocean heat intrusion that the Science Advances study identified as the driver of the Antarctic sea ice collapse. When warmer ocean water reaches the ice shelf, the floating extension of the grounded glacier that reaches into the Southern Ocean, it melts the ice from below, destabilizing the entire ice sheet system. The Thwaites Glacier, often called the Doomsday Glacier by science communicators for its potential contribution to global sea level rise if it fully destabilizes, is grounded in exactly this kind of below sea level bedrock, vulnerable to exactly this kind of warm water intrusion. The Communications Earth and Environment paper published in June 2026 stated that extreme environmental events in Antarctica are occurring with growing frequency and severity and will become more pronounced under continued global warming. The research argued that scientific operations in Antarctica will face mounting challenges as extreme events increase. This is scientists saying in a peer-reviewed journal that the events we are already seeing, the heat waves, the sea ice losses, the atmospheric river events that pushed temperatures 70 degrees above average in 2022, are not the outliers. They are the new baseline from which future extremes will be measured. For U.S. coastal communities, the most direct pathway from polar ice loss to lived experience is sea level rise. The tide gauge records at cities like Miami, New York, Charleston, and Houston already show accelerating sea level rise over the past 2 decades. Every inch of additional sea level rise converts a storm surge that currently reaches the first floor of a building into a storm surge that reaches the second floor. It converts a king tide that closes a road into a king tide that floods a neighborhood. And it narrows the margin between a manageable hurricane landfall and a catastrophic one. I want to bring this back to the immediate because I think the polar story can feel abstract in ways that make it hard to connect to the weather you are experiencing right now. Let me be specific. The August jet stream pattern, which is directly influenced by the temperature difference between the warming Arctic and the mid-latitudes, is showing the classic El Niño summer signature that I have been tracking since El Niño's confirmation in June. A persistent ridge over the western United States, active storm tracks in the northern plains, above average temperatures across the southern tier of the country, below average precipitation in the Pacific Northwest, while the southeast continues to deal with flooding from the moisture pipeline that has been running all summer. The Met Office's August 2nd briefing noted that July in the Antarctic continued the theme of lower pressure and strengthened westerly winds in the Southern Ocean, but with much higher pressure in the Amundsen Sea. That higher pressure in the Amundsen Sea is part of a global wave pattern that connects all the way to the northern hemisphere jet stream configuration I described above. The atmosphere is one connected system, and the polar changes I've described this morning are embedded in a global circulation pattern that is expressing itself in the weather you are experiencing this week. For the next 7 to 10 days, the El Niño-driven pattern shows continued above-average temperatures across much of the central and southern United States, with the heat dome that has been the dominant weather story of summer 2026 maintaining its presence over the west and shifting periodically toward the south and southeast. Flood risks remain elevated in the northern plains and upper Midwest, where the active storm track continues to deliver heavy rainfall to saturated ground. The wildfire risk across the west, driven by the combination of drought, above-average temperatures, and low fuel moisture, remains at elevated to critical levels through August. None of those weekly weather features are random. All of them trace back to the same root cause, a global atmospheric circulation that has been reorganized by El Niño, building on top of a long-term warming trend, expressed at the poles as the simultaneous anomalies the Met Office documented on August 2nd, and expressed in the continental United States as the most active and deadly heatwave season in years. I want to close with something I believe deeply, which is that the polar story is not separate from the preparedness story. The changes at both ends of the planet are not happening in a laboratory or a satellite image. They are happening in the same physical system that produces the weather you experience, the sea level that affects your coastline, and the wildfires that threaten your region. If you live on the Gulf Coast, the Atlantic seaboard, or any low-lying coastal area, sea level rise is not a 2050 problem. It is a problem that is already affecting your flood insurance rates, your storm surge vulnerability, and the frequency with which your neighborhood's lowest streets flood during high tides. The ice loss at both poles that scientists are documenting right now is the physical process driving that acceleration. Understanding it is the first step toward the kind of community-level planning that makes the difference between adaptation and catastrophe. If you live in the western United States, facing another year of drought, heat, and wildfire, the Arctic amplification that is slowing the jet stream and producing blocking heat domes is the atmospheric mechanism behind your suffering. The fires are not random. The heat is not random. The drought is not random. They are all expressions of a changed atmospheric circulation pattern whose fingerprints are visible in the August 2nd sea ice data from both poles. And if you live anywhere in the country and you are experiencing the sense that the weather is getting weirder, more extreme, more persistent, more surprising, you are right. And the places to look for the explanation are both ends of the planet, where the changes are most dramatic, most clearly measured, and most directly connected to everything else. The Met Office published Arctic and Antarctic sea ice data on August 2nd, showing the 9th lowest Arctic extent and the 5th lowest Antarctic extent simultaneously for the same date. The Science Advances study identified the mechanism behind Antarctica's shocking collapse and warned the system is behaving in a different manner. Scientists documented simultaneous extreme heat events at both poles in 2022, pushing temperatures up to 40 degrees Celsius above average in Antarctica and 30 degrees above in the Arctic at the same time. The Communications Earth and Environment paper confirmed that extreme events in Antarctica are occurring with growing frequency and severity. El Niño is confirmed, strengthening towards super El Niño status, and connecting the polar changes to the heat waves, the droughts, the floods, and the wildfire risk that have defined the summer of 2026. This is the most important long-range weather story of the year. Subscribe and turn your notifications fully on right now. I'm going to keep covering the polar systems, the El Niño evolution, and their connections to the weather you experience every day. Because these stories are not separate. They are the same story, and it is not over. Share this with everyone you know who wants to understand why the weather has felt so different in 2026. Because the answer is at both ends of the planet, and it is right there in the data that was published 3 days ago. Hit that like button so this reaches more people who need to see it. We will see you in the next forecast.